Howdy, here we go. This is Unit 2, Video 3, Finding Inverses. Anyway, while I go through this lesson, I've got a couple things to show you. I wanted to bring out my old TI-83 Plus just in case some of you guys are using one of these. And I wanted to let you know, if I turn this thing on, it's not as dark, or not as bright. It's harder for people to see this on the camera, so I don't like to use this one for that. But if you have a TI-83, I just want you to know all these buttons are the same exact things as on the super fancy schmancy ones. And when you go to mode, you'll notice this menu looks slightly different than the newer calculators. Well, guess what? This thing is locked and loaded in what's called classic mode. There is no choice for it. So if you have a TI-83, you got a great machine. It's going to work. This was my first calculator to use in the classroom like this. So all the stuff on this is the same as the newer one. So I was going to use this for a couple examples, but I don't need it right now at all. I'm going to turn it off for now and put it aside because really the math we have to do to answer these questions is not that bad. Now here's our practice. Here's the work. It says find the inverse of the given linear functions. Write your final answer using inverse notation when appropriate. Don't leave negatives in the denominator also. So use inverse notation when appropriate. Also, don't leave negatives in the denominator. So here are your 10 questions I'm going to ask you to find the inverse for. Now, one thing that makes these all the same is they are all linear. These are all lines. I had you do a lot of line practice in the summer packet. Linear equations. So y equals mx plus b format. So what you'll notice here, and I did this on purpose, let me show you the answer key for these 10 problems. Okay, let me get starting at number 1. Sometimes people get confused when they check their answer because they express their answer in a certain format, and then they go to look in the back of the book and the book doesn't have the same format. So here's the thing. If you have not figured this out yet, a lot of the work I'm having you do is I hand wrote it on worksheets because I have got to get you guys through this entire class in 12 weeks. So I took some information from our book and condensed it down so that I'm not saying turn to page 127, do these odd, do these even, do these. And the other thing is, in our book, you only get the answers to the odd questions. You don't get the evens. I need you to check your work. That's how you get better as a math student, is by checking your work. So I'm not going to give you this speech again, but that's why I always write out my practice problems handwritten, just so you have them all in one place. You don't have to fish around in the book. Also, here's every single way you could express these answers. Now, here's the thing with this. I'll show, there's 10 answers, by the way. So let's do this. Let's pause it, take a picture of it. So you got the first 7 answers. Then pause it, take a picture of it. Then you got the remaining 3 answers. But just for kicks, since these ones are super elaborate, that's not. There's only one way somebody would write this answer. Same thing with this guy. Nobody's going to change that up. It's very simple. But when your answer results in something fractional, like number 5 here, the thing is, if you're going to check it using a technique I'm going to show you on the calculator, this is the way you'd want it to look. Number 5 would want to look like this. It's the easiest way to check it on the calculator. If you want to check it algebraically, I'm going to show you that too, you would want to express your answer like this. But if you looked in our book, you would see that every single inverse is written in y equals mx plus b style. All 3 formats are correct. They totally are. But if you want to check it using your calc, this is the best way. If you want to check it algebraically, that's the best way. If you look in our books, since these are all linear inverses, they wrote every answer y equals mx plus b style in your book. Okay? So, I have some examples we're going to go through, but you have the practice problems. You got the answer key. So let's talk about finding inverses. So here we go. If you're going to find an inverse, the first step is write the problem in y equals form. Sometimes they are already written that way. Sometimes they are not. If the problem is not written in y equals form, you do it. Then you take the x and y variable and you just flip-flop them. You interchange where the x and y are. Then you solve for y. You get y by itself again. The result is called the inverse of the original function. So, just like I did before, I've got some practice problems. We're going to go through them. Then I'm going to show you how to check them with a calculator. I'm going to show you how to check them using algebra. Okay, so let's play. Here's my first example. I got to move some. So here we go. So I'm going to move this down, but you could pause that. Sorry, you could have paused that and taken a picture of it. Let's play. So here we go. This guy's already written in y equals form, so I go cool. I'm going to interchange where these guys are. I'm going to put the x here, and then I'm going to put 3y minus 4. I interchange x and y. I don't change the location of anything else. I leave the 3 right there. I don't touch this. I just put x where y was. Now, I got to get y by itself. So I say plus 4, plus 4. I move the 4 over. That cancels. I end up with, on one side of my problem, I have x plus 4. What does it equal? It equals 3y. Well, y is not by itself yet. So what am I going to do? I'm going to divide both sides by 3. So if I divide that by 3, it cancels. I get 1y. I do. Over here, I'd get both things get divided by 3. Now, see that format right there? That is a really good format to use if you want to check it algebraically. But if you want to check it using your calculator, you're going to find out that you want to put this in parentheses. Why? Because every calculator has the same problem. It only knows how to divide one number by one number. So the calculator sees this as two separate things. You want the entire thing divided by 3. Now, what's the other way around that? Well, I could write it the way the book does. Y equals, and then in the book they said there's 1x. So they said 1/3 x plus 4/3. This is a totally correct answer. It really is. That's y equals mx plus b format. That's what our book uses. If you write your answer like that, it's totally right. I give you full credit. Me gusta. If you write it like this, that is also full credit. Me gusta mucho. También. This format right here is much easier to punch into your calculator than this is. Okay? So, we'll talk about the algebraic check, but I want to do the graphing calculator check with you right now. Here's the way we check something using the graphing calculator. So here we go. We got a little bit of explanation here. To check, okay, so we're going to say checking with the calculator. All right, so we're going to do this. We're going to graph the original and the result, which would be called the inverse. So I'm going to check this with my calculator. I'm going to have to graph y equals 3x minus 4. I'm going to have to graph y equals 1/3 x plus 4/3. But when I punch it in the calculator, I'm doing this. Then, after I do that, I am going to graph y equals x. I'm going to graph the line y equals x. And if y equals x splits my picture down the middle, I have done my algebra correctly. Okay? Now, what we're working on today, finding inverses, this is true for no matter what kind of function. If you do this, you'll find its inverse. But linear ones are the easiest ones to do, so that's what we're going to start with today. So, when we check it with a calculator, number one, graph the original and the result. That's the inverse. Graph the line y equals x, and y equals x should split your picture in half. It should cut it right down the middle. So here we go. I'm going to grab my TI-83. I'm going to go old school. Let me get my paper set over here a little bit. Sorry. Okay, so I can see my two functions that I have to graph. I'm going to grab my calculator, which, by the way, I have already zoomed standard and all that. So I go y equals, and the first graph I'm going to enter is 3 x minus 4. 3x minus 4. I'm sorry, I'm out of frame there. Then I'm going to graph on the next line. I'm going to go down one. I can graph more than one thing at a time. And I'm going to punch it in this way. I'm going to go parentheses, x plus 4, close them, divide the whole thing by 3. Now take a look. Before I go, because I'm going to go down and I'm going to graph y equals x here. I am. But take a look at what we have so far. Let's look at the picture. Here's the graph. Look at that. Boom. Boom. That's what it looks like. Now, if these two dudes are truly inverses, this graph should be split right down the center by y equals x. Y equals x is always the third graph you draw. So here we go. Ready? Split it right down the center. Boom. There it is. Splitting it right down the middle. So what that means is if I were to take this and flip-flop that picture over that line, if I were to rotate that picture over the line in the middle, I would generate the exact same picture. All right, so that is how you use a calculator to check your work. Now, good for you, I made up an answer key, so you can just look at the answer key. But let's suppose I make you do this on the exam that I give you, the assessment that goes with this. Can you check your answer to make sure it's right? Chaw. Yes, you could. That's a thumbs up. Chaw. Okay, I'm going to go to my next example. So I'm going to put down my calculator and I'm going to go like this. I'm going to say unto ye, here's my next example. My next example is not written in y equals form. So my job is to get it in y equals form first. I see that this is a negative 4y. So you know what? I'm going to move this to the other side. I want that out of there. If I do that, it's gone, but I'd have to add it over here. Okay. I don't want the 5 here, so I'm going to take it away from this side, and I'm going to move it over here. So I'm doing a little bit of manipulation. What's left on this side of the problem? Over here, I've got 2x minus 5. What's it equal? It equals 4y. I'm going to divide by 4. Now I have y equals form. Y equals 2x minus 5 over 4. Hey, now I can actually find the inverse. Are you kidding? We haven't even done it yet? No. It has to be in y equals form to start with. Y equals form. Now I can begin. Switch x and y. So now I'm going to find the inverse. So let's find the inverse. So I'm going to say let's invert this thing. So I'm going to put the x where the y is. Let me move over a little bit. X equals 2y minus 5, the whole thing over here divided by 4. Now, algebraically, this is, I love when I see this because back in the 4th grade, they showed me something called a proportion, I can put a 1 on the bottom there and make it look like a fraction equal to a fraction. And then what did they tell us in proportion land? You can cross multiply. So 4 times x, I get 4x. 1 times that, I get that. Now, we still have to get y by itself, but that's easy peasy. Add 5, add 5. So on the one side of my problem, I've got 2y. So let's re-examine this. On one side of my problem, it says 2y. On the other side of my problem, it says 4x plus 5. Let's get y by itself. Bam! There it is. So y equals 4x plus 5, the whole thing over 2. Now, this original, there's my original. And you're like, no, it isn't. Way up here at the top, that's the original. No, no, no. I got to get it in y equals form to find its inverse. So this counts as being the original. Okay. Down here, this guy right here, y equals, I'm just going to rewrite it. Y equals 4x plus 5 over 2. That guy's my inverse. How do I check it using my calculator? Well, here's one thing. I personally do not like to convert these into y equals mx plus b form because it makes it harder to check it algebraically. It makes it harder to check it graphically. If I want to check this graphically, I want this in parentheses. So that means up here, I want this in parentheses. That would be the best format to check with my calculator, because my calculator gets confused if there's two things divided by one thing. But in our book, here's how they wrote it in our book, just so you know. And I have nothing against the book. I don't know if you guys hear my dog in the background. He's in trouble now. In the book, they would split it and say 4x divided by 2 plus 5 over 2, and then they would reduce this part, and they would say 2x plus 5 halves. So that's how it looks in our book, and that's why you'll see on my answer key, some of the problems have an answer that looks this way. But I'm going to graph it to check it. So here we go. I'm going to go grab my calculator. I'm going to move this over to the side a little bit, because if the original, and let's say I found the inverse correctly, then I should be able to check it using this. So I'm going to turn this on, and I go, crud, what's that? Well, that's the last problem I did. So I'm going to go back to y equals, and I'm going to clear this one out. I'm going to highlight this, clear it out. I'm going to leave this guy here because I need him to check my graph. So the original function is going to be parentheses, parentheses, and then I'm going 2x minus 5, close the parenthesis, divide the whole thing by 4. That's my original. Then I go down a level, and I'm going to say parentheses, 4x plus 5, close it, divide by 2. So I have everything in the way it should be. Take a look. That's how it should be. Now you'll notice if you're using math print, yours might not look exactly like this, but that's okay. As long as you got all the ducks in a row, the stuff where it goes. So let's take a look at the graph. Here we go. There's my first graph coming out. That's my original. That's my inverse. And if I did it right, this cuts it right down the center. Cha! That looks pretty centerific. Okay? Which means if I flip and flopping, if I were to fold it over that line, I'd get the same picture, and I surely would. Okay. Now, here's one thing. I'm just going to mention it since we got the calculator right here. On the zoom, you'll notice even on the old calculator, here, the 83, it has zoom square. I'm going to go to zoom square. That's function 5. So I'm just going to hit the number 5. And check this out. What zoom square does is, and some people don't like this, some people do like this. Some people like this because to them, it makes it look more symmetric. See, your window, what you're looking at here is a rectangle. It's a rectangle. So it distorts your image slightly. If you hit zoom square, what it does is it tries to compensate for that. It actually just adds more dashes on the x-axis so that it's uniform all the way around. That's what it does. So anyway, zoom standard, if I go zoom standard, look, it's going to redraw it, but you'll notice there's less dashes on the X now. And that's a personal preference thing. Some people go, you know what, I don't care. But hey, you want to know something? When somebody messes up algebraically, it's usually the tiny stuff. So here's what I want to show you. Look, let's suppose I accidentally on the bottom here had, instead of 2, what if I had -2? Hey, that's a sign error. People make sign errors all the time in algebra. But the thing about a graphing calculator is you're going to know right away that that's a really bad answer. Check out what it looks like now. There's the original. And then here's the inverse. And then here's the splitter. That is so not looking symmetrical at all. That looks, I mean, it looks like 3 lines that cross each other, but that's it. So when you are checking your work with a calculator, it is really, and you know what? I want to get rid of that. I can delete it. There's this button here, del. You can just delete that negative you had on there, and then boom, it's back to normal. But one of the things you notice with the calculator is if you make a sign error or you put a 2 and it's supposed to be a 3 or something on accident, it really sticks out like a sore thumb. So there we go. That's the good answer again. Now, I'm going to put the calculator aside. I'm going to show you the next 2 examples. Then we talk about algebraic checking. So here we go. I'm going to turn this off for now. And let's look at this next dude. Here we go. Here is my third one, and it's using function notation. Alrighty, guys. Back in the day when the math geeks were hanging, there was this guy who said, you know what? My name is Leibniz, and I don't like when people confuse me. So I'm going to invent this thing to use called inverse notation. So when it's a y equals format, we don't ever have to worry about it. When it's y equals, your answer is y equals. Take a look. Here's my answer key. Any of the problems on the original practice that I started with y, I end with y. But look at this. See, this guy says f -1 power x. This does not mean -1 power at all. It's used to tell somebody this is an inverse of the original function. This means inverse. So let me show you what they're doing. First off, I could switch x and f of x. I could, but it looks icky. It looks really spooky. Remember, f of x is a fancy way to say y equals. So whenever I have to find an inverse, no matter what it is, I always rewrite it in y equals form. Hey, that's the first step anyway, write it in y equals form. Then I'm going to switch the x and the y. So don't lose sight of it. This was my original, okay? This was my original up here. But if I switch the x with the y, I get x equals 2/3 y minus 1/5. Now, there's different ways to solve for y. There really is. But me, I am all about fraction busting. Okay, fraction busting is my preferred method because it is a good habit to get into that lasts a lifetime. When you, no matter how complicated things get down the road, this is a good trick. So here we go. I'm going to take this and I'm going to say, you know what? Pretend that's got a denominator. I'd write it in. It's a 1. That guy's got a denominator. It's a 3. Does this y go with the top or the bottom? Ooh, we've run into this predicament. If it's not clearly written in the bottom, it goes with the top, right? So I'm going to rewrite this and I'm going to say x over 1 equals 2y over 3. minus 1/5. And I'm going to say, you know what? Fraction busting is all about multiplying everything in this statement by the least common multiple, by the LCM. 1, 3, and 5 all go into 15. They all go into 30 too. Not 32, but 30 also. But 30 is not the least common multiple. 15 is. So I'm going to say let's multiply everything here by 15. If I multiply everything in an equation by the exact same thing, I'm not really changing it. 15 times x, what do I get here? I get 15x. Equals, if I did 15 times this, well, 15 times this, 3 goes into 15, 5 times 2, I would get 10y. Minus, 5 goes into 15 3 times. 3 times 1, I'd get 3. So I got it to there, and now I don't have any fractions because I like to get rid of them. Fraction bust. A fraction busted. Get rid of the fractions. That trick is totally awesome. You don't have fractions now. Let's finish. I want to add the 3 and divide by 10. I want to add the 3. So what do I get? I get 10y all by itself. What's it equal? It equals 15x plus 3. I'm going to divide everything by 10 now. And I'm going to say y equals 15x plus 3 over 10 is my inverse. That's my inverse. But here's this dude, Leibniz, who comes along and he says, you know what? The original function was called f of x. I am going to instead not call this thing y. I'm going to call it f inverse x. You heard me right. This stands for the word inverse because in math we are extremely lazy when we can be. I don't want to write out this function is the inverse of the other one. So I say f negative 1x, and it's written like a power, but it's not a power. What does it equal? It equals this, 15x plus 3 over 10. So this guy right here and the original dude up here are related to each other by the concept of inverse. If the original problem says f of x, my answer should say f inverse x. Let's look at the instructions again. Find the inverse of the given linear functions. Write your final answer using inverse notation when appropriate. It's not appropriate here. We don't do it. It's not appropriate here because it's written in y equals form. But you better believe it'd be appropriate here. My answer for number 3 better say f inverse equals and then whatever it is. And guess what? My answer for number 3 on the answer key says f inverse equals right there. So let's finish this baby off. If I want to check it using my graphing calculator, I would want this in parentheses. I would want to lock that thing up. In fact, there is no f inverse thing on my graphing calculator. There isn't. When I turn on my calculator and I go to graph something, I don't have an f of x, I have a y. So I'm going to clear this one out, clear that one out. I'm going to leave the third one because I need it. But let's enter this in. Now, hey, see this guy? If I want to enter this in, be careful. Sometimes your calculator messes up fractions because it doesn't know where to put the x. Do I put the x on the top or the bottom? So, guess what? Here's what I'm going to do. I'm going to put the fraction part in parentheses. I'm going to say parentheses 2/3. 2 divided by 3, close the That's how I tell my calculator 2/3. 2 divided by 3, I lock it up. Then I go x. Then I'm going to say minus 1/5. Minus parentheses 1 divided by 5. Close the parentheses. That's how I tell my calculator 2/3 x minus 1/5. That's how I do it without it messing me up. Then I go to the second function. But now I could type it in like this. I could. So I'm going to type it in the second one, parentheses. What am I doing? Parentheses 15x plus, whoops, plus 3, close the parentheses, divided by 10. Now, if I did this right, graphically, this is going to look perfect. Let's see what it looks like. Let's see what it looks like. Oh, this better split it right down the middle in it. It's success. How beautiful is that? That's totally beautiful. So it worked out. It worked out. Now, guys, just so you know, I wanted to use my TI-83 in case some of you guys have TI-83s out there. But it doesn't show up on the video as good as well. I don't know. I ain't no English teacher. But so I'll use my other one. But we only have one more example to check. So I'm going to turn this off, get it out of my way. And here's my last example. My last example is g of x. Hey, g of x. And here's another thing. That's a mixed number. It's a pain in the butt to enter mixed numbers in on the calculator. It really is. So if you see this, because I'm going to do this to you, rewrite it. Just say, you know what? I might as well go for the gusto right here. I'm going to rewrite this thing in y equals form, because I should. Instead of g of x, I'm going to use y. Why? Because that's just a fancy way to say y. Equals negative 2x, and then I'm going to convert this and say minus 21 fourths. That's what I'm going to do, because that's going to be the format I'll use if I want to check it on my calculator. Then, what would I do? Let's invert it. I already wrote it that way, so let's find the inverse. Let's invert this. So I'm going to do x equals negative 2y minus 21 quarters. And I'm going to bust that fraction because I likes to fraction bust. And I'm going to multiply this entire thing. Oh my God, I'm trying to make a bracket. That was so bad. Times 4. Kaboom, kabang, kabizzle. 4 times x, what do I get? 4x. 4 times that, I get negative 8y. 4 times that, the 4's cancel. Oh, that's why I did it. And I get negative 21. Hey, let's get y by itself, and then we can call this thing the inverse. So I would add the 21 to the other side, which would then leave me with this guy all by himself. So I would have negative 8y is equal to 4x plus 21. And then I would divide by negative 8. And I would divide by negative 8. Now, y equals divided by negative 8. If I'm going to check it on my calculator, that is a totally fine way to do it. Except for I'd have to lock this up in parentheses. I would. But I want you to look at this. One thing I wrote in my instructions. Don't leave negatives in the denominator. Why? Because it's a bad habit. It's a bad habit you're going to have to break. So you might as well not do it from the beginning, right? So instead of leaving the negative on the bottom, put it on the top. So if I'm going to rewrite this, I could rewrite it with the negative on the top. But remember, if I take that negative and I put it on the top, it's no longer in the bottom, because a negative divided by a positive is the same as a positive divided by a negative. But it would actually hit both pieces of the top. So that is one beautifully written problem. It totally is. Me gusta mucho. In fact, your calculator would like that too. It's easiest to check it by punching it in like that. But you'll notice if you wanted to, you could distribute the negative through the top. You could say it's negative 4x minus 21 all over 8. Or you could do what our book does and write it in y equals mx plus b form. And in the book, they said, you know what? That would be reducible. We would call that not negative 4/8 x. In the book, they would say we could call that negative 1/2 x. And then here would be minus 21/8. So this is a fine answer. It's in y equals mx plus b form. It's just not very useful. This is a fine answer. It is. That's a fine answer. They're all right. So look back at your answer key. I wrote all these answers in 3 different ways if it was possible, because I like them all. This one's easiest to graph, so let's check it. But before we do, what does the answer key say if you look at it? It does not say y equals, it says G inverse X. That is a fancy way to say, I am related to this. Okay. But if I'm going to graph this on my calculator, guess what? I'm going to graph it this way as a improper fraction. So y equals, clear, clear. I'm going to do the, oh, sorry, you can't even see what I'm doing. So I'm going to go negative 2x minus parentheses 21 divided by 4. So that's 21/4. I'm going to go down to my new inverse, which is negative parentheses 4x plus 21, close the parentheses, all divided by 8. And if I look at this, check this one out. Now, every graph that we've done so far has the same vibe to it. This one has a slightly different vibe, but you know what? It's still symmetric. If I were to fold this over the line, if I were to fold it over, I'd get the same picture. But it's kind of hard to tell on these, so I'm going to show you one thing. Right above the zoom button on your calculator, it says format. You can go second zoom, and you know what? You can turn your axes off. You can turn your axes off. And when you look at the picture then, there's no x, y coordinate stuff in your way. So it makes it easier for some people to see that it did split that graph right down the middle. I don't want to forget that I turned my axes off and then use this calculator and go, where is everything? So I'm going to go second zoom. I'm going to go back to format. I'm going to highlight axes on and turn it back on. Okay, now we have a couple functions to play with. Right here we have this guy and this guy, okay? But I want to go back to my other one that I just did, because in this example I used g of x just to show you that you can call it, g inverse x. But here's my last thing of notes for you for this lesson. Algebraic checking of inverse functions. If 2 functions are inverses, then f of f inverse of x equals f inverse of f of x. And whether you do it this way or that way, you will get x for an answer. What? It means if you compose, so you do a composition of functions. If you compose a function with its inverse, you will always get x as your answer. So let me show you this one, right? So we did f of x, here was my original problem. F of x equaled 2/3 x minus 1/5. Then, when we did the work, when we did the algebra, we got this answer. F inverse x, this is from example 3. I'm just taking example 3. What did I get? I got 15x plus 3 over 10. Now, if I plug this function into this one, or vice versa, I will get the answer x. Now, what if they used the letter t instead of x? Well, then I would get a t. What if they used m? Well, then I'd get an m. But I'm using x, just because we usually use x's and y's. So, see this guy here? I'm going to do this. I'm going to go f of f inverse of x. So what does it mean? I'm going to plug this guy into this guy. So f of x says whatever you give me, I'm going to multiply it by 2/3. Whatever you give me, I'm going to multiply it by 2/3, and then I'm going to subtract 1/5. That's what f does to whatever you give it. So 2/3 times this. Don't freak out. It's okay. I could do 2 goes into 10. I could cross cancel. I'd get a 5. I would. Then I would go 3 times 5 is 15 on the bottom. So what do I have? I have 15x plus 3, the whole thing over 15. I do. Minus 1/5. Oh, yeah, you can read that. There. Sorry, I didn't do it where you could see it. So all I did is I plugged it in, but it's multiplying 2 fractions, so I can cross cancel. Now, I'm going to split this up, and I'm going to say, you know what? I could write this as 15x over 15. I could. Plus 3 over 15. Sure. Minus 1/5. Now, take a look. What is 15 fifteenths? That's just 1x. Hey, doesn't this reduce to be 1/5? And then 1/5 take away itself? That would just cancel. Grand total, what do I get? X. My answer is X. Now, some people say, that looked worse than graphing it to check it. I agree. It looks a little bit worse than graphing it to check it. It does. But you know what? I didn't have to do F inverse to do it. Let me show you on another page. Ready? Once again, what was my first function? I'm going to just do this. The original function that we had was f of x equals 2/3 x minus 1/5. What is the inverse that I found? Well, the inverse that I found was 15x plus 3 divided by 10. Now, I could have done it this way to check it. Because the beauty of checking an inverse is, if you graph it, I showed you already how to graph it. It's a visual check. You go, oh, visually that looks stunning. Then, if you're going to do it algebraically, now I'm going to take this guy and put it into this guy. So what does this guy do for a living? This guy says, whatever you give me, I'm going to multiply it by 15. Then I'm going to add a 3 to that, and then I'm going to take the whole mess you just gave me and divide it by 10. Now that looks bad until you actually do the very first step, which is distribute. If I distribute this, 15 times 2/3, heck, 3 goes into 15, 5 times that, I end up with 10x minus, and I'm just working in the numerator, 15 times 1/5, I get 3. So this part right here, when I multiply it, I get 10x minus 3, plus 3 more, and the whole thing is divided by 10. Well, this takes out this, so I end up with 10x over 10. And then I go, 10 goes, bam, sweet, I'm there. Now, most people will say, do I have to check it this way? Only if the teacher forces you to do it, I guess. I'm not a big fan of forcing people to do anything because I know that you have 2 methods to check your work. You could graph it or you could do this. And I got to tell you, this is not bad to me, but the next lesson, checking an inverse using this trick for the next stuff, because all the stuff that we do next is not linear, they're actually super easy. So it all depends on the type of thing you're checking. Only do, so anyway, check out this one. Like the very, easiest, most basic one, the very first question, hang on. The very first question I give you on the assignment, I gotta slide down, sorry, is y equals 2x plus 1. So let's say they called it f of x equals 2x plus 1. And then if you check your answer to problem number 1 on my practice sheet, you will see that it's written in y equals form, but I'm going to write it in inverse style. And I got this for an answer. See this? This is when an algebraic check is not so rugged. This is an easy one. I'm going to do it this way because I can pick whichever way I want to do it. Do I want to do f of f inverse or f inverse of f? In this situation, it was easier to do that way, I think. But when I look at this one, I'm making this judgment call. This guy right here will get plugged into here. So what does f do? It takes whatever you give it and multiplies it by 2, and then adds 1. Hey, I could just cross-cancel those. And then what do I get? X minus 1 plus 1. Well, what's it equal? It equals x. Done deal. That is algebraically how you check an inverse. So, once again, what are the topics we covered today in this lesson? Well, we talked about finding linear inverses. There's many different ways you could express your answer and still be correct, totally. And then we talked about what does it really mean to find an inverse? Well, it means write it in y equals form, interchange x and y, solve for y. And then if you're going to graph it, oh, I'm sorry, it's on that page. If you're going to graph it to check it, that's how you do that, graphing calc check. And then if you're going to do it algebraically, that's what that means. All right, guys, you have 10 questions to practice. And I don't care which format you want to write your answer in. It's up to you, whatever makes you happy, as long as it's correct and it checks. Okay, hasta luego. That's Spanish for bye.